Brought to you by JEGS.
This is a highlighted top part from Dorman products. New to the aftermarket, our direct replacement suspension trailing arm bracket fits popular Buick, Chevrolet, Oldsmobile, and Pontiac applications from 2014 to 1997. Due to the high rust-prone rate of the original trailing arm bracket, Dorman has updated the bracket to include an epoxy E-coating for extra protection. Additionally, our suspension trailing arm bracket includes mounting hardware for a complete and convenient repair.
Howdy, this is Lemmy with Dorman Products, here to talk to you today about some of the products coming out of our steering and suspension division. We make a great many parts, but in this video, we're going to focus on the suspension half of that equation and cover some items like control arms, ball joints, bushings, and lateral links. A vehicle's suspension system is what allows us to have a comfortable ride and lively, predictable vehicle handling. But it's also a critical safety component. In addition to helping drivers maintain control over the vehicle's direction of travel, suspension also comes into play in many vehicle crashes. The forces imparted through vehicle steering and suspension parts during even what may seem like a mundane crash are great, and we in the industry are responsible for protecting our customers, be it through recommending replacement of worn parts, installing them, or building them. At Dorman, we take that task very seriously by developing and rigorously testing our components to ensure wide safety margins, because we know our customers' lives just may depend on it. Our ride is excellent, of course, but that's secondary to driver and passenger safety. It's not enough to bolt onto the car and function. The suspension has to be designed to be protective in the event of a crash. Today, I want to take you on a bit of a suspension show and tell to illustrate some of the protocol we have in place to make sure our products are the very best, and where some of our competitors may not be putting customer safety first. If you're buying Dorman suspension, know that name can be trusted. Let me show you why. We got a few parts up here, but I want to start out with the ball joint because it's an area that's so easy to get wrong. The ball joint is a ball and socket joint at the end of the vehicle A-arms. It's constructed a lot like your shoulder is. A telltale spot where we see cost cutting with bargain basement suspension is in the ball size. Rather than match OE, many of our competitors will just pick a ball and cup size that are convenient and cost efficient for them. And you'll never see the size cheated upwards because that would take more material and add to the cost. Instead, they'll cheap out and use smaller balls and cups to keep the price low. However, this is a bearing surface. If you reduce the size, more force and wear is exerted on a smaller bearing area. We don't do that. We match original equipment ball stud size or increase it. After making our ball studs, we heat treat them. This is a pretty tricky process. The steel needs to be brought to the correct temperature, held for long enough to uniformly treat the entire part, and then be cooled via quenching. Now, when done properly, the result is an increase in strength without becoming brittle. We use our impact tester to simulate sudden side loading of a ball joint, the type of forces a ball joint might deal with in a wreck or a curb shot. What do we benchmark from? OEM, you guessed it. Let's look at the results. Here's an OEM unit which is bent but not broken. Picture perfect. Ours looks very similar. Here though, you can see competitor A, which has become brittle and broken. Even worse, competitor B, which has a tiny hairline crack in it. A tech undercar will at least see this broken unit, assuming everybody survived. But this greatly weakened cracked unit, put some dirt and road goop on there and the best mechanic in the world's gonna miss that. Scary stuff to think about someone's family blasting around in a car with that thing on there, isn't it? After we heat treat our ball studs, we bring them to a high polish, which you can see here. That luster is never seen by a customer, but we do it because it promotes joint longevity. The competition? Well, they use stuff like this. See those striations? Those are from the manufacturing process. This piece is created on a lathe, and those lines are where the bit chews through the metal to shape the part. Without further micro-polishing, however, those ridges grind away this guy, the polymer cup that lives inside most ball joints. This, however, is just the tip of the iceberg. We just talked about ball joints. Other critical items include lateral links, control arms, and control arm bushings. When we come back, I'm going to show you how we stack up in those departments too. Up until this point, we haven't discussed metallurgy. But even though we may toss around terms like steel or aluminum, the reality is that both metals are alloys. And there are thousands of different alloys with varying formulations and properties. We test the chemical makeup of the metal used for specific applications, making sure the tensile strength is on par with OEM test results, as well as our own requirements. This is critical because simply adding more metal to achieve the same strength usually isn't possible. We create uniform pieces of metal from suspension parts known as coupons. We cut these coupons from OEM suspension pieces, as well as our own and those of other manufacturers, then test them empirically in our tensile tester. By testing a uniform size against known samples, we can compare, contrast, and select various metals with different makeups and properties. After analysis, we can create the arms and then test them to make sure we're equal to or better than the OEM strength. Only then can we create our own specifications, which are often more stringent yet. We recently set about making control arms for a Tesla model. We tested OEM arms and our competitions before releasing our own A-arms. We realized Tesla had chosen to use a state-of-the-art alloy that was both strong and light, which makes sense on a heavy electric vehicle sold at a high price point. When we cut our coupons, we found our competition was using a rather common grade of aluminum in their arm, but there was just one problem. It was weak, which we verified through an independent lab. In testing, the competitor's control arm for that Tesla simply didn't make the grade. But they don't advertise that on the box, do they? Instead, they use an inferior metal and pocket the profit, and customers have no real idea. Our chemistry show and tell doesn't stop at just metal. Let's examine this item here, a control arm bushing. This bushing serves to help isolate suspension movement from the cabin, leading to a ride free of harshness. Normally, these are made of a metal insert that accepts a bolt and a metal sleeve that presses into the control arm, and the insert and sleeve are joined by a rubber cushion. It's critical the rubber isolator have a strong bond to both sections. So here's a couple bushings where we've performed push-out testing, measuring the force required to separate the insert from the sleeve. We're effectively testing the integrity of these bushings. In this test, we're looking for a strong bond of the rubber to the metal substrates. Here's ours. Note the rubber is torn away close to neither the insert nor the sleeve. But see this competitor's bushing? Note how most of the rubber tore away right near the insert. This could have happened due to a dirty or oily insert, an improper rubber cure, inferior rubber, maybe something else totally. What does matter here though is that this bushing might look as durable as ours in the box, but it's not. The rubber and steel separate easily. Moving on, we have a few lateral links you can see here. Right here is an OEM unit. We can cut it open, you can see it's got a nice finish inside. Here's our unit, also nicely E-coated inside. However, when we cut open one of our competitors' lateral links, you can see rust forming in here right off the shelf. That's because they weld the control arm bushing area incorrectly, leaving no vent for the E-coat to flow through, like you notice here on the OEM lateral link. Let's look next to another control arm. Within this arm here is some steel bracing, helping keep the arm strong. Here's the competition's with tiny little spot welds holding the reinforcement plate. And then here's ours with nice long beads of weld, making sure that under normal suspension flex, this plate's not gonna pop loose. Isn't it interesting how many of these cost-saving measures our competition has in place can't be seen easily? Speaking of things that aren't easily seen, let's examine a truly scary scenario next. Our competitor has a control arm that they ship, and seemingly thoughtfully, they include new hardware here for the ball joint. The problem, however, is they use some off the hardware store shelf piece that isn't actually compatible with the vehicle. Note here, we have the factory control arm and knuckle. We've cross-sectioned the knuckle so you can see the interface between the arm and the knuckle. Note that the ball joint stud comes through and terminates rather quickly. That's to leave room for the wheel and tire, which run very close to this area on vehicle. Because of that, the hardware here is bespoke. It's recessed into the knuckle to offer good thread engagement, but also offer a low profile. This hardware is very expensive for us to tool, but we do it because it's completely necessary. Let me show you why. Now examine this same setup with the hardware the competition provides. Note how few threads are actually engaged here. Best case scenario, this is being installed by a tech who knows something is amiss and orders proper OEM hardware. But worst case, what if this is a DIY job that goes awry and the control arm lets loose from the knuckle at speed? I don't really want to think about that. Without OEM style hardware, this is a ticking time bomb. We're not alarmists, but look, some of this stuff is downright unsafe. That lack of safety may stem from incompetence or ignorance rather than malice, but the end result is the same. People wind up in cars that are markedly less safe than they were built to be. And that's why you should always stick to an experienced brand you know like Dorman, and not just the cheapest product you could find, even though they might often look the same. That's gonna wrap up this video. If you need anything at all, the Dorman technical support team is always handy to help. Thanks for checking out our video on our vehicle suspension components. I'm Lem, and I'm out of here.
Brought to you by JEGS. Delivery. Your source for high performance and quality. Delivering performance since 1960. JEGS.com.